All right, so now let's talk about what it means for two sets to be equal. So we're going to start with the definition. We're going to say given sets A and B, A equals B. And the way we're going to denote this is with an equal sign, just like you would think. If and only if every element of A is in B and every element of B is in A. So basically, saying that they have to have the same exact elements in it. So according to the definition, A equals B if and only if A is a subset of B and B is a subset of A. So again, we're going to look at an example here. Let's define sets A and B as the following. So A is going to be all of the integers that you can write as 2 times an integer. And B is all of the integers that you can write as 2 times an integer minus 2. And I want you to prove that A equals B. Okay, so we're going to prove that these two sets are equal. So my proof will start off. If I look back at my definition, I have to show two things. If I look, I'll underline it here. I have to show A is a subset of B, and then I also have to show B is a subset of A. So really you can break this proof down into two parts. So I'll call this first part part 1. What you need to do is you need to show that A is a subset of B. And we're going to do this with our element argument. So we're going to take X, let X be any element of A, and I need to show that that's an element of B. So what does it mean to be an element of A? It means I can write it as 2 times an integer. So then I can write X as 2 times A for some integer. And in order to show it's in B, I need to have this form here. So in particular, I need this minus 2 that's on the end. So I'm going to rewrite this. I'm going to write X. If I want to have a minus 2 on the end, I need a plus 2 so that they cancel out and it stays the same. And then I've got my minus 2 on the end. I'm going to rewrite this first part as 2 times A plus 1. So now this thing in parentheses I have here, this A plus 1, I'm going to call that B. So let B be A plus 1, which is an integer, because it's a sum of integers. So we've written X as 2 times B minus 2. Therefore, X is in B. And I can now say A is a subset of B, because I took an arbitrary element out of A and showed it was also an element of B. Now the part 2 to this proof is you need to do the reverse. You need to show that B is a subset of A. So I'm going to now start with an arbitrary element out of B. We're going to let X be any element of B. Now, what does that mean? That means I can write X as 2 times B minus 2 for some integer B. And I want to show that this is an A, so I need to write X as 2 times something, and that something will be B minus 1. So I would let A equal B minus 1. Again, that's an integer. It's a difference of 2 integers. Therefore, X is 2 times A, and we've concluded that X is in the set A. This means that B is a subset of A, because I took an arbitrary element out of B, showed it was in A. And now we're going to put our 2 parts together to make our final conclusion. So we showed in the first part A is a subset of B. In the second part we said B is a subset of A. This means that we can conclude that A equals B. And we've completed our proof, so we put a filled in square here to say that our proof is complete. And we've shown that these 2 sets are in fact equal.